Hello, I'm Francisco Brasileiro. I'm here to present the grid interoperability work developed by the EELA2 project. The EELA grid is formed by dedicated resources that run gLite and shared resources that run OurGrid. We have implemented a gateway that allows these two parts to interoperate. Our solution leverages the native incentive mechanism of the OurGrid middleware to provide a simple yet very efficient prioritization policy for the sharing of resources between the two grids. In an OurGrid system, resources are organized in sites. Each shared resource runs a worker component that monitors the resource activity. Sites are managed by an OurGrid peer. Whenever a resource is idle, its associated worker notifies the peer. The peer is in charge of keeping this information. The peer is also responsible for interacting with the peers in the other sites so as to discover remote resources that may also be available. Jobs are submitted to the grid via a broker component that interacts with the local peer to get access to local and remote workers. OurGrid uses a very simple prioritization mechanism. Each peer keeps a balance for every other peer in the system. This balance accounts the difference between the amount of computing power that the peer has used from the other peer and the amount of computing power that it has donated to the other peer. When there are more than one peer willing to use a grid resource, the peer that manages the resource donates it to the peer to whom it owns most. This simple mechanism assures fair allocation of resources. The gateway technology we use is the 3G bridge proposed in the context of the EGEE's project. Jobs are exchanged by configuring the gLite user interface and the OurGrid broker to route jobs to a central 3G bridge. The 3G bridge maintains a database with the jobs that have been submitted. A middleware-specific adapter translates jobs in their native format to a canonical format defined by the 3G bridge. Jobs are dispatched to the appropriate grid with the help of middleware-specific plugins. We have developed a Java implementation of the 3G bridge and plugins for both gLite and OurGrid. The OurGrid plugin is implemented as a modified version of the OurGrid broker. A peer representing the gateway is instantiated to serve this broker, and jobs are submitted to the OurGrid system through the broker as if they had been submitted by the user. On the other side, the adapter that allows OurGrid jobs to be stored in the gateway's database for execution in the gLite system is implemented as a modified version of the OurGrid worker. The broker sees this special worker as a normal worker that is managed by the gateway peer. The fact that jobs submitted to this worker are actually executed in a gLite grid is completely transparent from the broker's perspective. The gateway peer assures that the exchange of resources between the two grid systems occurs in a fair way. Moreover, since local users always have priority over remote ones, it's always guaranteed that the quality of service of each individual grid is never diminished by the fact that they can now interoperate. In summary, OurGrid complements gLite in many ways. It is an excellent middleware choice for tapping shared resources into a service grid, exploiting them opportunistically and in a controlled way. If you'd like to have more information on this work, please attend the poster session that will take place Monday 7 p.m. or pay us a visit at the project's website.